Okay, so let's talk about a relation. The definition, a mathematical definition of a relation. So a relation is a set of ordered pairs. That's what a relation is, a set of ordered pairs. Okay, so for example, these are relations that I am about to list. So examples of relations. Y equal 3x minus 1. This equation is considered a relation. Why is it considered a relation? Because if you graph it, you're graphing what? Ordered pairs. X and Y, right? In fact, what kind of equation is this if you were to graph it? Linear. You would get what kind of graph? A line, right? 3x minus 1. Y equals 3x minus 1. Okay? 2, x squared plus y squared equal 9. That's a relation. If you were to graph it, you'd be graphing ordered pairs. So this is a set of ordered pairs. In fact, you remember what number 2 looks like? Nope. Huh? What'd you say? It's a circle. X squared, y squared, right? You had that on your test for 1. X squared, y squared. The center would be what here? The origin, very good. The center 0, 0. What's the radius? 3. All right, so this is a circle. And remember when we talked about circles, we said the circle is a set of ordered pairs, a set of points. So that's a circle. This is a line. Those were on your last test. 3. X squared plus y equal 3. That is a relation, because if I were to graph it, I would be graphing a set of ordered pairs. Do you know what graph that is? That's a parabola, because if you get y by itself, you get y equals 3 minus x squared. So that's a parabola. Now, sometime in the near future, we're going to be graphing parabolas, more complicated parabolas. All right. So then you have things like this: 2, 5, negative 6, 3, 7, negative 2, 0, 1. So this is also a set of ordered pairs. In fact, it looks like a set of ordered pairs, right? In fact, this set number 4 has how many ordered pairs? 4. Numbers 1, 2, and 3, how many ordered pairs are in 1, 2, and 3? An infinite number. Remember, a line has how many ordered pairs on it? An infinite number. A circle has how many ordered pairs on it? An infinite number. A parabola has how many ordered pairs on it? An infinite number. This relation right here has how many ordered pairs? A finite number. How many are there? 4. You could also represent a relation using a graph. So a graph is considered a relation. Why is a graph considered a relation? Because it's made up of a set of what? Ordered pairs. All right, so those are all examples of relations. Now, some of those relations are considered functions. Not all of them, some of them. So let's talk about what a function is. All right, a function is a special kind of relation. A function is a special kind of relation. A function is a relation in which for each x coordinate there corresponds exactly one y coordinate. So a function is a relation in which for each x coordinate there is exactly what? One y coordinate. That's the definition of function. You have to know the definition in order to be able to understand what a function is. So for each x, there's what? One y. Notice I didn't say for each y there's one x. I said what? For each x, there's one y. Not the other way around. All right, so let's look at some examples. So the examples will be these. Okay, number one, determine whether each relation is a function. Then determine the domain and range. All right, so I'm going to give you a set of ordered pairs. That's the first one we're going to look at, set of ordered pairs. And then you're going to determine if it's a function. But you got to know the definition of function. What's the definition of function? A relation in which what? For each x, there is exactly one y. Not two y's, not three y's, not four y's, but how many? One. Now, in terms of domain and range, you had that in your first test. What was the definition of the domain? Set of x coordinates. Definition of range? Set of y coordinates. You had, there was on your last test in terms of that circle. Remember you had to find the domain and range of a circle on the last test? All right, number one. Suppose I had this set of ordered pairs. 4, 5, comma, 6, 7, 8, 8. All right, so again, we're going to be dealing, first of all, we're going to be dealing with a finite set. So how many points does this set have? 3. All right, and you want to determine if this relation is a function. All right, so the best way to deal with that is this idea. So we can look at this in terms of a mapping. All right, so you may want to use this idea of a mapping. You don't have to, because some of you can look at this right away and determine whether it is or not. But you may want to use the idea of a mapping to help you. So I'm going to kind of draw something that looks like this, 2 of them. This is my x, this is my y. And I'm going to list the x coordinates in this one and the y coordinates in this one. So my x coordinates are what? Meaning my domain. What's your domain? 4, 6, and 8, right? The range has what coordinates? 5, 7, and 8. All right, now let's start with the 4. Notice that according to this first coordinate, when x is 4, what's my y coordinate? 5. So I'm going to draw an arrow from 4 to what? 5, like that. Then we'll draw an arrow from 6 to what? 7. Then we'll draw an arrow from 8 to 8. Now, let's use this idea of a mapping with the definition of a function. A function says for each x, there's only what? 1 y. So for this x equal 4, there is what? 1 y value. What is it? 5 only. No other arrows coming from it, right? When x is 6, there's only 1 y. What is it? 7. When x is 8, there's only 1 y. 8. So is this a function? Yes, this is a function. All right, number 2. Suppose we had -3, 5, 6, 2, 5, -1, 4, 5. So we have this set of ordered pairs. It's a finite set. Finite meaning I can count how many set of ordered pairs I have. How many are there? 4. So some of you can look at this right away and determine whether it's a function or not. Go for it. If you can't, you may want to use that idea of a mapping. So we can list the domain. Remember, the domain is a set of x coordinates. So what are the x coordinates here?
-3, 6, 5, 4.
All right, like that. And then we're going to list the range. And what's the range?
Between -1 and 5.
Right, now if it occurs more than once, only list it once. Is that clear? If any number occurs more than once, only list it once. So 5, 2, -1, and 5 I already have. Don't list it again. List it once. Okay, now let's go and talk about the correspondence. -3 corresponds to what y coordinate? So I'm drawing an arrow to it. 6 corresponds to what y coordinate? 2. 5 corresponds to what y coordinate? 4 corresponds to what y coordinate? All right, so that's what I have. Is that a function or not? Okay, so a majority of you said no. What is the definition of a function? For each x, there's what? 1 y. So let's talk about that. When x is -3, how many y values are there? 1. When x is 6, how many y values are there? 1. When x is 5, how many y values are there? 1. When x is 4, how many y values are there? 1. Now I'm going to ask you again, is this a function?
Yes.
Yes, this is a function. For each x, there's got to be what? 1 y, and we did. It's okay to have more than 1 y value for different x's. You just got to use your definition of function. For each x, there is 1 y. Notice one arrow going from each one. Okay? Let's look at this one. Let's suppose we had 0, -2, 4, 6, -1, 5, 0, 8, 1, 4. All right. So I have this set of ordered pairs. So I have this relation. It's a set of ordered pairs. It's a finite set. I can count how many set of ordered pairs there are. There are 5 of them. Is this a function or not a function?
No.
Does anyone think it is? All right. If you're not sure, then do the mapping. x, y. What are your x coordinates? 0, 4, -1. I already have 0 and 1. What are your y coordinates?
-2, 6, 5, 8, 4.
Okay. When x is 0, let's start with the first point. When x is 0, it gets mapped to what number? -2. When x is 4, it gets mapped to what number? 6. When x is -1, it gets mapped to what number? When x is 0, it gets mapped to what number? 8. And in fact, I can stop at that point. Because notice when x is 0, how many y values do I have? 2. In order for it to be a function, I've got to have what? 1 y value. But you can go on. When x is 1, what's my y value? 4. All right, now, listen carefully. So you may be asked to explain why this is not a function. Okay? So let's explain. So this is not a function. Let's talk about why. Because you got to tell me what part of this makes it not a function. What makes it not a function? The x coordinate of 0. So you would say something like this, because when x is 0, there are, how many y values? 2 y values, that's why. There are 2 y values. There's got to be how many? Just 1. Okay? All right. So given a set of ordered pairs, it's not difficult to determine if it's a function or not. If you need to, use the mapping that we did here. Now, I've got to go back and actually list the domain and range. So you're going to say domain equals, now it's a finite set, right? You all agree it's a finite set? Guys, are each of these relations finite or infinite? Finite. You can count them. 3, 4, 5, finite. So since it's a finite set, you're going to use a set notation, and you're just going to list the numbers, just like you did here. So you're just going to say what? 4, 6, 8. That's your domain. The range equals
5, 7, 8.
5, 7, 8. Remember on your first test, when you listed domain and range, that was not a finite set. You remember that? That circle? You had to do an interval instead. You don't use an interval here. You don't use an interval here because it's a list of finite numbers. How many are there in each one? 3. That's how you do it. Notice no interval. You only do an interval when it's an infinite set. So compare that with what you did on that first test in terms of that circle. Over here, what's the domain? Only list it once. Only list things once. -3, just list them as you go around, across. They don't have to be in order. 6, 5, and 4. What's the range? 5, 2, -1. Only list it once. If you listed 5 twice, you'd be upset with me. And number 3, what's the domain? 0, 4, -1. We already have 0 listed. And then 1. And what's the range? -2, 6, 5, 8, and 4. All right? Okay. Now, go ahead and take out that handout I asked you. So what we just did was I gave you a finite set of ordered pairs. So the first 3 examples were a finite set of ordered pairs. Those relations were a finite set of ordered pairs. Some of the relations were functions, some were not. Okay? All these are relations, correct? In numbers, the first two graphs, are those relations or not relations?
Yes.
They're relations. Why are those relations? It's a set of ordered pairs. All these points on here are ordered pairs. Now, is it a finite set or an infinite set? It's an infinite. That's an infinite set of ordered pairs. Okay, so let's talk about the idea of function with regards to the graph. Listen carefully. If I asked you if x is, let's say, -2, if x is -2, what is or are the y values? Singular or plural? When x is -2, you got to look at your graph. It's kind of blurry up here, but look at your graph. When x is -2, this is -2 for x, right? How many points are on the graph when x is -2? 2. When x is -2, I get this point here, and what's that y value? 1. And then what? 11. So my question right away is this a function? No, that's not a function. Because when x is -2, there were how many y values? 2 of them. There were 2 of them. In fact, if I asked you how many y values are there when x is, let's say, +2? How many y values are there when x is +2? First of all, you got to be able to do this that I'm about to tell you. You got to be able to locate the points on the graph when x is 2. At this point, to be honest with you, all of you should be able to look right away, tell me what points in the graph have x equal 2. So you should have been able to do this. Go to x equal 2, and then here's this point. I'm darkening it. Y'all agree that's x equal 2 right here. And then here's the other x equal 2 right here. I don't care what the y value is at this point because I would have to estimate anyway. But the question was this: how many y values do I have when x is 2? 2 of them. See that? Okay. So based on our discussion at this point, is this a function? No, it's not a function. This is not a function. Okay? All right, let's go to the second graph. All right, I'm going to ask you this question. When x is, let's say, 6, when x equals 6, what is or are the y values?
7.
Is it just 7?
Yes.
Yes. Good. When x is 6, right here, that's the point 6,7, right? My y value is 7. All right, I'm going to ask you this then. What is the y value when x equals, let's say, 1? What is the y value?
4.
Okay, what's the answer?
4.
Yeah, right here, 4. Let's say it's close to 4, right? So let's say 4. It's not quite 4, but it's close to it. So I'm going to just say approximately 4. In fact, if I ask you this question, for each x value, 1.2, 1.08, -10, for each x value, how many y values do I end up with?
1.
Just 1. For this x value right here, there's only 1 y value. For this x value right here, there's only 1 y value. So notice, for each x value, there is what? There is only one y value. Okay? For each x value, there's only one y value. So is this a function or not a function? It's a function. This is a function. Okay, now based on our discussion with that circle and this parabola, there is something called the vertical line test. So listen carefully. You remember a while ago I asked you when x is negative 2, how many y values were there for that circle? When x was negative 2, how many y values were there? 2. So if I draw a vertical line through that circle at negative 2, see it goes to the x-axis negative 2? It intersects a circle how many places? 2. Right here and right here. That means that for that x value, there's how many y values? 2. So listen carefully. I'm going back to that second page that has that circle again. When I draw this vertical line, whatever that x value is right here, whatever that x value is, how many y values were there? 2. This y value and this y value. If I draw a vertical line here, how many times does it intersect the graph? Twice. If I draw it here, how many times? Twice. Okay? If I go back to the parabola now, remember we talked about when x was 6, how many y values did I have? 1, it was what number? What value? 7. So if I draw a vertical line, notice this vertical line intersects the graph how many times? 1. That means that for that x value, there's only what? 1 y value. For this x value, there's what? 1 y value. For this x value, there's what? 1 y value. For this x value, there's 1 y value. So going back to this right here, no matter where I draw a vertical line, no matter where I draw it, every time I draw this vertical line, it intersects the graph how many times? Once. If I draw a vertical line here, it intersects the graph how many times? Once. But then I'm going to ask you this. We said it was not a function, but it intersects it once. What's the issue? And here's the issue. If when you draw a vertical line and it intersects the graph more than once anywhere, then you can say it's what? Not a function. So here's the idea of vertical line test. If this is called the vertical line test. The vertical line test can help you to determine if a graph represents a function. Okay? So you use it with a graph. So if when you draw, let me write it this way, if when you draw a vertical line everywhere on the graph, everywhere, and there is at least one place where it intersects it more than once, intersects the graph more than once, then the relation is not a function. So whenever you draw a vertical line anywhere on that graph, and you have at least one place where it intersects more than once, then we say it is or is not a function. It is not a function. So the circles you had on test 1 were those relations functions or not a function? Not a function. Not a function. This parabola, is that a function or not a function? It's a function because no matter where you draw it, it only intersects it how many times? The vertical line only intersects it how many times? Once each time. Okay, let's go to the next one. When you drew lines, now I'm going to be careful with what I'm about to say. When you drew certain lines, let's look at this one. Is this line a function or not a function? It's a function because no matter where I draw this vertical line, it's going to intersect it how many times? Once. Remember what that means? That means for each of those x coordinates, there's what? One y coordinate. So that's a function. This line right here, is that a function or not a function? It's not a function. Very good. Because if I draw a vertical line, that vertical line intersects it how many times? When x is 3, I want you to see this. When x is 3, how many y values are there? An infinite number. Y can be 4, y can be 3.78, y could be negative 4.6. There's an infinite number, right? So there is, I'm just going to say there's more than one y value. In fact, there's an infinite number. So there's at least more than one. There's 2 or more. So this is not a function. All right, the next one. Soon, you're going to be graphing you're going to be graphing polynomial functions. That's chapter 3, by the way. Graphing polynomial functions is chapter 3. And that's how some of them are going to look. Are these functions? Is this one a function? I'm sorry? Okay, I haven't talked about the bottom yet. I'm only talking about the top one, okay? Okay, so that's the only one I'm looking at right now. So is this a function? Yes, because no matter where I draw the vertical line, it intersects it once. What about this one? Okay, look, look very carefully. Right here, when I draw this vertical line, it only intersects it once. So why isn't it a function? Because there are other places where it intersects it more than once. So that's not a function. All right, so that takes care of that. So given a graph, you can easily determine if it's a function or not. Okay? All right, so that was that one. So I think that was all the graphs on that part. Okay? So that's called the vertical line test. All right, now,